I'm Phoebe, I'm here from Team Alpha, and we're going to present our project Anthropometrics today. So, what's our project about? So we've been assigned a project by the Fitzwilliam Museum, and we're essentially trying to create an exhibit for the museum. What they've given us is a set of historical records from an anthropometric study that was done back in the 1880s. This study was looking for a correlation between various different facial measurements and degree class. We're really trying to bring this data set to life by taking visitors to the museum and matching them to some historical twin from this data set. And that's done by using computer vision techniques on photographs of our user. So how does our application work? We take two pictures of our user, we take a front-on picture, we take a side-on picture, and then we perform analysis on these images. Using this analysis of the images, we present a record card to the user where we report various information. So you can see here we're reporting the name of the match from the data set, some information about the data set match, the user's own head measurements that we calculated, and the head measurements of the match from the data set. So, how are we choosing this twin that we're reporting back from the data set? The first thing we need to do is we need to calculate the actual measurements of our visitor to this exhibit. So two of the things we're measuring are ocular width and face width. We measure this using the Python package face recognition, which is a machine learning package that identifies the key points you can see here on the face. We measure ocular width in terms of pixels, just by looking at the difference between these average eye points identified by the machine learning package. And again, we can identify the face width measured in pixels by using these two key points you can see here and here, measuring the width of the face that are again given to us. This gives us measurements in terms of pixels, but by taking pictures at a fixed distance with a fixed camera, we're quite easily able to calibrate that, and then we can take facial measurements in terms of centimetres. Another measurement that we're taking is something that I call profile length. So that's this distance here. This is much harder to do with machine learning techniques. There's just less sort of visible features compared to identifying a face. So we're doing this with a thresholding technique against a white background. The measurement that we take is the width of the widest black band across the middle of the picture. So you can see that's giving this measured in terms of pixels, and then exactly the same, we can apply our calibration again, and then we've measured the profile length of our user. So now we've got these measurements, what are we going to do with them? So we've got to find the closest historical twin from our historic data set. What we do is we use a nearest neighbour algorithm to return some set of nearest neighbours from the data set. Then we randomly select a twin from the set using probabilities biased according to the distance from our user to each set member. The reason for introducing this randomness is that if a lot of people with very similar measurements that are perhaps not that close to the mean of our data set, for example, a group of children, are to use this application, we don't want to be matching them all to exactly the same data set member. For very similar reasons, we make sure that you can never select the same twin from our data set twice in a row. So I think this worked really well, but there are some extensions we could make. We weren't able to get our hands on the real anthropometric data set just because of some data access issues, data protection. So it would be really cool if we could just swap our databases over and use the real data set. There'd be no issue with this because they're following the same schema. It would also be pretty cool if we could present some more information about the twins to our users. We thought it might be particularly interesting to present the professions of the twin. It might be interesting to predict our users' grades by using the grades that the twin got. But again, this isn't data that we were able to get hands on with the time that we had. But overall, I think our project worked out really well, and we had a lot of fun as well. And thank you from Team Alpha.